And good morning. Good morning. And so how's your math going today? My math is good because last time I talked to you was on Thursday, and I was like, oh, I don't have anything written except for the definition of strongly compact cardinals. And then you can see a little Amy. There she is. And that's all I had. And then on Friday, I'm gonna get stuff ready so that on Monday I can just have a lot of stuff ready to go to talk about. And what happened was, and what happened was, on Friday I woke up and I was like, wait a minute, it's like I'm thinking about this further research for degrees for strongly compact cardinals, and I was like, wait, I don't think anyone's like actually defined the degrees of strongly compact cardinals, like using the embedding definition, like was done by Mitchell, like was done by Vika and Miha, and the paper about Ramsey cardinals, just like I did for the Mitchell rank for super compactness. So I was like, oh, well, no one's done that yet, so that's what I'll do. So I went to New Paltz because they have a lot of coffee shops there. I just felt like it needs to be a cool coffee shop. So I went to New Paltz and I was like, I'll write this down. So I wrote it down, and I think it works out. And I sent it to Arthur after, and he said, yeah, I think that makes sense, and I don't think that anyone's done that yet. So that's great, yay. And then I finished the whole chapter, so I finished everything. And I don't know, I had a magical writing day. I mean, it happens sometimes, once in a while. I woke up and I was like, before I even got out of bed, I just like wrote the story about the temptation. And then I just, that day I just got everything done on, I suppose it was Saturday. So Friday I went to the coffee shop, wrote degrees. Saturday I wrote everything. And then Sunday I drew the pictures. So it's all done. So when you see this, probably you already saw the article. Okay. So I'm really excited about that. I would say you don't need AI, you need AA. And that's Arthur after. Yeah. So it's great to like be able to ask an expert. Plus he gave me a lot of ideas for the reading, like the books, articles to read about strongly compact cardinals. I mean, the Magador one is the one that I picked, and that's that's like one of my favorite ones. That's like one of the most famous ones. Okay, so I just wanted to. So I hope you like the story, the strongly compact. I'll let you read the story itself. I had fun writing the story and making the pictures, and just I love Magador's writing. Some people's writing, like Magador, like Reinhardt. I'm sure there's others that I've read. It could be written today, and the way they write, it's like it could be written today. It's so clear. Okay, I know that sometimes there's technical articles you can't write like that, but for what they're writing about, I mean, it's a technical article. His article, Magador, and like he's using killing he's killing cardinals with forcing, and that's how he gets his result. But I'll let you read about that. And I just wanted to share about the degrees of strongly compact cardinals. So let's put the first slide up. Aaron, thank you. Okay, so the definition of strongly compact. There's lots of definitions. One of them is you're strongly compact if you're theta strongly compact for all theta greater than kappa. And so that means that there's an elementary embedding, J from V to M, with critical point kappa. So far, just like a measurable cardinal or a strongly compact cardinal, and then there's the extra stuff. And this is more like, strongly compact cardinals, again, the definition is so like, if you have this, then you have this. And I feel like in this definition, the embedding is sort of like a communication between V and M. And M is, I think M is really identifies as kappa maybe, because like M was made from kappa. It was made from an ultra product kappa, using an ultra filter on kappa. Okay. The ultra product was made from using an ultra filter on kappa. Okay, so it's a theta strongly compact if it's an embedding from J from V to M, the critical points kappa, such that for all T subset of M, so T is not an element of M, and somehow we can see T. So where the cardinality of T and V is less than or equal to theta, there's an S in M that contains T as a subset, and according to M, the size of that S is less than J of kappa. So it's not that big, I guess. You could think of it like that. Because this theta, I think that this theta could really be anywhere in M. On the M side, it could really be anywhere, but it's like I think of it like we have some kind of kappa through M, through J of kappa, has some kind of knowledge of something bigger than it. And that's kind of what the idea of strongly compact cardinals kind of is. Like, Kappa, an ultrafilter on Kappa, or a filter on Kappa, because it's made from the stuff of Kappa, it's so good that it gives you an ultrafilter. Or because this M was made from Kappa, it's so good it can even see things that aren't really inside of it. Something like that. Okay, so you can see this picture here for Kappa is theta strongly compact. Okay, and the definition, equivalently, there's a Kappa complete fine measure on P kappa theta. So equivalently, there's Kappa complete fine measure on P kappa theta. Okay, I'm having some trouble with the Substack using writing a line of tech. So in this article, you'll notice that I don't say P kappa theta. I don't actually write that because I can't use it. I can't write it in Unicode, so if I can't write in Unicode, I can't do it. But it's in this one because I just screenshotted this from Overleaf. But yeah, so the definition does look a little complicated, kind of, but when you think about it as this communication between V and M about what M knows about theta, it's all about what does Kappa know about theta, I think. Okay, please let me know if you have other thoughts on that. Okay, sometimes the analogy and the definition get so close together that the analogy sort of becomes like the definition or something. But okay, it's really supposed to just help think about it. So then I'll just read this. So with this, so we can do the second slide now, Aaron. With this embedding definition, I can define the degrees or rankings of theta strongly compact cardinals by looking in M and seeing whether kappa is theta strongly compact there. So this is just like what Mitchell did for Mitchell ranked for measurable cardinals. It's just like what I did for super compact cardinals. And it never occurred to me, maybe it's occurred to other people, to do this, because it seems like it's a pretty, it's just right there, right? It's just right there. Okay, but great. I'm glad that I did it. Okay, whatever. Whatever. Okay, so now let's see the second, okay, we're going to see this other picture. So, the notation is it's theta SC for super compact, so this is STR for strongly compact, or look like star, the star ranking or something like that. Okay, so we just would say that the order on kappa, the order on kappa with respect to theta strong compactness is greater than or equal to 1 if kappa is theta strongly compact, for some theta greater than kappa. It's 0 if it's not theta strongly compact at all, and that's like the other definitions. And so I just defined 2, and then we can define the rest by recursion. Okay, so for 2, kappa's theta strongly compact, and there's a witness, J from V to M, and then kappa is also theta strongly compact in M. So what that means is there exists another embedding, J prime from M to M prime. Kappa is the critical point of J prime. And then for all T subset of this new inner model, there is, which is up to size theta, there's an S up to size theta in M. There's an S in M prime that contains T as a subset, and M thinks it's not that, it's less than J prime of kappa. Okay. And there is no greater witness of theta strong compactness in any other such M. So that means it's stuck right at 2. And you could also say M thinks that the theta strong compactness ranking for kappa is 1, and it doesn't have any other higher rankings anywhere else. Any other M's don't have any other higher rankings. Another thing you could say is that there's a kappa complete, the strong compactness ranking, the theta strong compactness ranking for kappa is 2. There's a kappa complete fine measure on P kappa theta. I just want to look at something real here. Yeah, okay. Kappa complete fine measure on P kappa theta in M. And there's no deeper inner models that have that kind of a measure. Okay, that's it. So, and I like how in the picture, it just worked out perfectly that you have J, V, and M talking to each other about S and T, and then there's room right next to that for now M can talk to someone else. But M only has to talk to 2 people, the model above it and the model below. And then that model down there, if you want to have higher degrees, that model has to talk to another model inside. They all can stand next to each other. Okay, so I would say, so thanks so much for listening, and I hope you like the article, and let me know. And so the question is, I think, well, what do you think about the degrees of strongly compact cardinals, and is there some degree of theta strong compactness that implies theta super compactness? that would be interesting. Okay, so that's that. And like I was worried about this section. I definitely, I guess you could say now that I'm out of it, I could say I had a writer's block. It wasn't so much like, it was just like, I felt like it was gonna be a little boring, and I don't want to just write something. Here's the definition of strongly compact, and like I wanted to have something that you can like grab onto, and I felt like I finally got that, and it all came out in one day. And so I will say that sometimes with writing, I have noticed that if I just like don't do it for a little while, I may have that luxury, I guess. I mean, if I just don't do it for a while, it builds up, builds up, and builds up, and then it'll all come out in a couple days. Whew. Okay, so it's great. So it ended up being really great, and I can't say, ask me 2 weeks ago, I wouldn't have said this, but it worked out. Okay. So thanks so much for listening, and it's motivating to come here. And I hope you like the article. Just let me know what you guys think about the strongly compact degrees and just the story and stuff if you like it. All right. Thanks so much. I hope you're having a great mathematical day, and we'll see you soon.